So hello and welcome to the webinar on MSc PG Actuarial Science program at University of Southampton. So I am the program lead for this program, and today I'm going to give you an overview of our program. I'll first introduce our program structure and talk a little bit about master's projects. I'll then tell you about where our students can work after they graduate from this program, what facilities and extracurricular activities we have in the university. And finally, I'll give you an example of our fantastic and exciting research that we do here at Southampton. So, okay, let's start with our program structure. So first of all, we would like our students to have a strong, solid quantitative background. As you know, this is because the program itself is a mix of statistics, stochastics, actuarial science, demography, economics, finance, and accounting. Therefore, this program aims to provide you with the technical skills in mathematics and a professional level education in actuarial science, I'd say. So this will prepare you to start on a professional career as an actuary. On top of that, we offer you the opportunity to obtain internationally recognized exemptions from the core principal subjects. They are CS1, CS2, CM1, CM2, CB1, and CB2 of the Institute and Faculty of Actuaries. So being recommended to all or some of these exemptions will give you a chance to enter employment with advanced professional standing, and it will save you some time during your career if you choose to be an actuarial analyst. Okay, so the first part of the program corresponds to postgraduate diploma in actuarial science or PG Dip Actuarial Science. And the first part is normally studied over 9 months full time and typically in 2 semesters. So in the first semester, you can choose these 5 modules where each module maps to a professional subject. So we have economics module, for example, which maps the CB2 exemption, probability and mathematical sciences maps to part of CS1, financial maths maps to parts of CM1 and CM2, parts of CM2, survival models maps to part of CS2, and actuarial maths 1 maps to part of CM1. Okay. In the second semester, you can choose other 5 modules, again, where each module maps to a professional subject from the Institute and Faculty of Actuaries. So we have accounting and finance module, which maps the CB1 exemptions, statistical methods and insurance maps to part of CS1 and part of CS2. Mathematical finance maps to part of CM2, stochastic processes maps to part of CS2, and actuarial maps maps to parts of CM1 and parts of CM2. So by taking these 10 modules, depending on your academic performance, you might gain exemption from all core principal subjects that we offer. That is, as I said, the 6 exemption recommendations from CS1, CS2, CM1, CM2, CB1 and 2. Okay, and the second, so after finishing the first part of the program, the students have the opportunity to obtain a master's degree if they want to in actuarial science. So this is in addition to the exemption recommendations. We have 2 distinct routes here. The default route is to take actuarial science case studies. However, sometimes some students have external fundings, maybe from an insurance company, and we try to accommodate this if those funding parties would like students to carry out a traditional 3-month supervised dissertation on a certain topic. In those cases, we're happy to consider the suitability and feasibility of the investigation formally proposed by either the student or the funder, and students to complete a 3-month dissertation. So as I said, the default option though for the MSc Actuarial Science is to complete 2 case studies. So I'll talk a little bit about them. Okay, so first of all, each case study takes 6 weeks to complete, and at the end of 6 weeks, students submit their reports for the corresponding case study. Case study 1 typically starts around mid-June with an end of July deadline, and we give 1 week of break between 2 case studies to give feedback to students before the second case study starts. And case study 2 typically starts around beginning of August with a mid-September deadline. So to compare to traditional dissertation, the case studies are more structured with some open-ended questions, and the students are provided more guidance. Extra workshops are also available through the university's library to help students on how to write case study reports or a dissertation. Okay. Okay, so after getting all these modules, writing up your case studies, after all that hard work, what can you do? Where can you work? Okay, let's go back. So in our program, actually, we will focus on giving you some skills as well as academic knowledge. So these include the the application analysis and interpretation of actuarial, statistical, and financial models, but some skills like personal organization and time management, problem solving, independent learning, and these are all very important and relevant skills for today's employment market. So as a result, there's quite a wide range of employment opportunities when you graduate from this program. So you can choose to be an actuary, obviously, but you're not limited to this by any means. You can choose to be a quantitative analyst, financial analyst, risk manager, statistician, mathematician, or a consultant, and you can work in a variety of places spanning from life insurance companies to governmental departments. Okay, let me tell you a bit about the facilities, events, and the Student Society for Actuarial Science at Southampton. So first of all, we have a lovely mathematical sciences student center where we use the space for a variety of activities, study, learning, social events. To give you some specific examples, in previous years, we used the space for active industry engagement like employer events, JP Morgan, First Actuarial, and many more visited us. But we also use the space for social events in the school like pizza and film night, end of year quiz night. So it is quite a nice bit of space, really. We also have an active student actuarial society called SUAS. This is Southampton University Actuarial Society. They organize most of the actuarial employer events. In the past, they regularly carried out actuarial careers fair where many representatives of insurance companies came to the campus and talked to our students, answered their questions, let that be about internship or permanent employment or training or anything you can think. They hosted events such as government actuaries department presentations, and they also organize social events like games night. Okay, so we also organize these high profile, for example, Worshipful Company of Actuaries annual lectures. This year, for example, in February, John Taylor, the president of Institute and Faculty of Actuaries, gave a very interesting lecture on the effect of artificial intelligence on insurance at the campus, Southampton. Okay, and finally, let me talk a bit about our world-leading research and give you an example on how we use our research in teaching and learning. Okay, so here is one example, and it is a very real-world example. So trillions of pounds are invested in pension funds worldwide, and pension funds have liabilities. The retired people and the people who will retire in the future will receive income in their retirement. So this is an amount promised to them. But to compute the size of this liability, one of the things we need to know is the expected future lifetime of pensioners. In other words, how long the corresponding pensioners will live, how long the pension provider will make these payments. So I guess nobody can tell exactly how long they're going to live. Similarly, the future remaining lifetime of pensioners is unknown, and it needs to be modeled. Some of you might have heard the concept of longevity. This is the risk of living longer than expected to the annuity provider. So in order to manage this risk, we need to, one of the things we need to do is to forecast mortality, model mortality. Okay. So a group of academics from the University of Southampton, including myself, involved in producing the latest English life tables published by the UK Office for National Statistics. So you might know that the life tables are designed to provide a snapshot really in time of the mortality experience for a country. So the decennial life tables, known as the English life tables, are an official publication. And these have been produced since 1841. So we're proud to be part of the history, really, by producing the latest English life table. There is a methodology. What we did, in a nutshell, is we smoothed or graduated the crude mortality rates using a combination of a generalized additive model and low-dimensional parametric models. In our modeling, we also incorporate the uncertainty, particularly in the highest age groups. So modeling the mortality for these oldest ages is very important, for example, when it comes to forecasting the pension liabilities. However, it is the trickiest as well because the data is sparse, and that is, so what I mean is we don't have a lot of data for these ages, so the uncertainty is the greatest. Okay, so after producing these the English life table 17, me and my colleagues were involved in a project to review the current practice of setting the mortality assumptions in the UK national population projections, again carried out at the Office for National Statistics. In the review, we have tried to answer methodological questions, including how to extrapolate mortality rates through the older stages, how to reduce the subjective assessment and correction, and project the future mortality improvement rates in the UK. So besides reviewing this ONS methodology and offering them some practical recommendations, we have also proposed a comprehensive, coherent, and flexible mortality projection method, and this was recently published in the Royal Statistical Society's journal. Now, this is all very exciting because I teach Actuarial Mathematics 1, so this is a module on life insurance mathematics, and the syllabus of the module involves life tables, survival analysis, pricing of annuities, which essentially pensions. And this is all very exciting because I can use the findings of these research projects I was actively involved in my teaching of in my Actuarial Mathematics 1. So this is just one example I can give of research-led teaching in the short period of time we have here. But I think it is important for students to see how they can apply their knowledge in real life and to see that there is an active research area for the topics they learned. So I think this is all I'm going to say for now. Thank you very much for joining the webinar, and I hope you found it useful.